Hi guys, this is a gray begon system. It's for Burning Man. A man named Larry Breed invented it. The Bureau of Land Management controls the laws and regulations for Burning Man, and one thing they mandate is that you get rid of all your gray water. So if you cook noodles or take a shower, you need to dispose of that water appropriately. Um, he designed a system that uses wedding veil material or tool, and it goes around two rear bike wheel hubs. I won't get too much into the mechanical details because there's really good descriptions of it all over the internet, and I can give you the link to the information that Larry Breed put out on the Evapotron, or the Gray Begon system as he calls it. Um, there is a pantyhose right here as a drive belt, and basically what happens is you put your gray water in here, and there's typically plastic liner in it, and as this bicycle wheel windmill spins, it um, it gets this pulley moving, and the gear ratio here is pretty significant. So with a lot of speed with this spinning, you can spin this barrel. This barrel will pick up your gray water. It'll spin inside this barrel, and the sun beating down on this in the desert will evaporate your water very effectively. The only problem is I went in 2000 and I think 11 to Burning Man, and there was very little wind, so our Evapotron didn't really effectively eliminate water. So what I did is I did a solar modification, and I hooked up an Arduino. So basically what I have is an anemometer. The anemometer is here, and as this spins, it has a little Hall effect sensor in there, and it's calculating an RPM, so I can figure out how fast the wind's going. And I also have a light sensor back here. So if I meet a couple conditions, if it's light outside and there's wind, then the system will stay off. But if it's light outside and there's no wind, or less wind than it takes to spin this, then it'll actually turn the solar on. And I have a large solar panel hooked up to a charge controller. So I'm charging the battery that this is pulling from, and it will continuously spin this barrel even when you don't have wind. It's the motor under load draws about 6 watts. With all the electronics and everything and drag and whatever else, I'm probably 6.5 or 7 watts. And I have a 120 watt solar panel, a 20 amp charge controller, so I am well adequately dissipating the extra power. So let me show you how it works. In this condition, it's technically light enough for how I programmed it. So if I go to turn it on, there's no wind. It should just start spinning the solar with solar power. That's because the anemometer is not spinning. If the anemometer starts spinning pretty quick, then it's letting the system know that there's wind. And since there's wind, it's going to turn off the battery power, and it's just going to pull from the wind power to spin the thing. So if I augment artificial wind here, you can see the anemometer spinning. It doesn't immediately turn off because I'm doing a running average. That way little wind gusts don't just turn the thing on and off. So once that average gets faster than a set speed that you can set with the small knob, then it'll turn off. So now the system thinks that it's windy enough to keep this thing going. It'll probably stop because there's really not enough wind. I'm just lying to the anemometer. So when I pull this thing away, the average wind speed from the anemometer will start going up or down, and then it'll go below my set point, and the motor will turn back on. Now I'll also show if there's no wind, so the solar, charge controller will turn on. The motor will turn on and get this thing spinning. But the sun is down, then it's not effectively probably evaporating water very well, so I'm just going to turn the system off. Plus at that time I don't want to drain the battery because I can't charge with the solar. This also is doing a running average, so it won't actually turn off right away. I don't want a cloud to go over and the system just turn on and off. So now it thinks it's dark out. It's dark out and there's no wind. So technically the only thing keeping it from turning back on is the fact that it's dark out. So I'll make it light again, taking my hand off the sensor. And that average light setting, it's something constant I want this thing to keep running into the evening hours. It's still warm outside. I figure it'll still keep working. It's not that critical, especially since this solar panel is so effective at charging. And this only draws 6 watts, so I don't mind that it's running for a few hours in the beginning and the end of the day without much solar charging going on. So now it thinks that the wind's back, so it turned the motor off and the solar panel can just go back to charging. And no power is being drawn off the battery while it's charging. This is probably not totally necessary. If I just want to evaporate more water, I could have just probably built a large evaporator or some other kind of system, but the idea of Burning Man is to innovate. So here I am. And turn off the system for just a moment. So what I have here for a motor is a 12 volt motor that spins at 10 RPM and it draws 6 watts. I tested it with my multimeter at 12 volt. I just calculated it because I tested the amperage going through it and know what voltage it is. I just have this all taped up because I just want to play with settings. And this is just literally my first test, my first mock-up. So I have this little Radio Shack enclosure that will hopefully keep most of the dust out. I tried to seal it off pretty good. And I have just a nasty mess of wires here, but I have my motor wires right here. It's all plug and play going into my box. And I also have power from the charge controller. This is the load wiring. And here's my little charge controller. I don't have the solar plugged in right now. It's just plugged into a car jumper, but it's 12 volt source, so it works. And I don't know how well you can see it, but there is a kind of in focus. The charge controller just has 3 different ports. You have your solar plus and minus, your battery plus and minus, and your load plus and minus. And the basic thing you have to do is look at if your load, if the combined amperage of your load and your amperage going through your solar doesn't add up to more than the amps of your charge controller, then you won't burn up your system. So mine won't draw any more than I think 12 amps, so it works out well. And I have an on-off switch here, so I can quickly just turn the thing off. And the really cool part that I did here was I adapted I don't know how to weld yet. Once I know how to weld, this will be a little bit easier. But the motor out here, I adapted to a bicycle freewheel. So that's how I can actually get this thing to spin with just the wind. And there's very little friction from the motor. It's in fact, it's freewheeling. Just like when you pedal a bicycle and you want to coast for a minute, you hear that clicky sound. You can kind of hear it here. So the chain won't spin in this direction, this direction here, but that's actually the force is being applied. The resistance is in this direction when the motor spins. So the cog will spin this way when the motor turns on, and it locks in this direction, just like your bicycle wheel, as if you're rolling this way on your bike. And so it can freewheel in this direction. So if the wind picks up, which, you know, it isn't conveniently doing right now, let's say it was, I'm just spinning it by hand, then it will just spin the drive belt and the wind will move this barrel and the chain freewheels. So it's a pretty neat little system, and I'll tell you how it works out at Burning Man. Maybe I'll take a little short video and put a link to it. I will also provide a link to the information for Larry Breed's Evapotron as it sits itself, which is more than adequate most years, but this last year it wasn't very the year that I went, it wasn't very windy, and I just want something a little bit more reliable. So I guess I'll talk about my anemometer real quick. I haven't quite finished it. I haven't secured my wind vanes. I wanted to put blades on here, but I don't want blades, standard blades, because I don't want to cut anyone. Figure people might touch this thing. And I have a simple Hall effect sensor in this aluminum tubing, and I embedded a magnet into a skateboard wheel. Let's see if I can find out where it is. So it's about right here. Yep, and the Hall effect, there's a small hole right up here in the aluminum on this washer that's in the inside. And every time this magnet passes that little hole, the Hall effect sensor toggles. It's a little digital sensor. It toggles. It's normally outputting 5 volts. When the magnet passes, it drops down to 0. So that is fed into a small Arduino microcontroller, and I did some programming to calculate the RPM. Inside this box, I can adjust the wind level that's required to spin this thing. You know, every system would be different, but, you know, I didn't necessarily know off the top of my head what wind speed would actually be required to physically overcome any resistance of the freewheel and the water resistance as this system is dipping into the water to effectively spin it. And instead of constantly pulling and reprogramming a chip, I have a little knob in there where I can adjust the required wind speed to get this thing going. So yeah, the system itself normally doesn't have the sprocket here. I just modified it to have a sprocket so that it can drive this wheel. This sprocket is normally on the other side. This is a rear wheel, and this piece of PVC is over where the cassette normally goes. And same thing on this side, it's another rear wheel. This is what the other one really would look like if I didn't have that cog over there. And the one side of the axle is here, and the bearing. And then on this side, you can't see it again because it's under the PVC, is a where the cassette would normally go. And that's it. The Evapotron is coated with a lacquer, like 5 coats. So the Burning Man dust would destroy the system, but we'll see how it works. Pretty excited. Got to do some refining and fix it up a little bit.